Hello everybody, welcome to Unit 8, where we're going to be talking about software engineering topics. And so what exactly does that include? Well, we're going to go over coding style conventions. This is something I really think should be done at the start of the class, but we don't want to bore you with the coding conventions off the bat, so we put it towards the end to give you a chance to actually get in and do some coding first. But we're going to go over those again and talk about some ways to improve the flow of your code. We're also going to talk about helper methods and how you can use those to help clean up your code as well. And we'll finally close with talking about encapsulation and using instance variables and local variables. After that, we're going to talk about algorithmic design with object-oriented programming and how you should go about thinking about your problems. And this includes top-down designs using stubs. And then finally, we'll talk about merging the driver method into a driven class. So we'll see how you can use a kind of like a test method for each class that you're building. And then finally, we'll talk about accessing instance variables without using this. We've already covered some of these style conventions, but we're going to go over some of them again because it's important that you understand how to properly document your code and how it will affect your performance when you're working on different projects. A lot of times you're going to be working on a certain section of code and it's going to make perfect sense to you while you're there in the moment, and then you're going to put it away and go work on something else, and then you're going to come back 6 weeks later or a week later, whatever it is, and you're going to have no idea what you were doing. It works that way. So documentation is absolutely critical. Not only self-documenting code, meaning the code explains itself, but also the comments that you put in to help you explain some things that maybe self-documenting code won't cover. So the first thing you're going to want to make sure you do is have a prologue at the top of every file. And in this, with the Park University style conventions, they follow Oracle. And I'm not prescribing that you follow one method or another. Wherever you work or whatever you're doing, you're going to have your own style guides for that organization to follow. You might even develop your own. But this is the Park style convention, so this is what we use. So you're going to have a prologue up at the top, which is basically a box of asterisks with the file name, the author, and then a space, and then the description of the class, okay? Underneath that, you're going to have a space, and then you're going to actually have the class. So this just helps break up the elements of the comment, right? So it's easy to see that, this up here is the metadata. This is like just general information. And sometimes you're going to have additional metadata that goes beyond the author and the file name. And then this down here is going to explain what the class is. And it should be just a really quick narrative just to make it apparent, if somebody's flipping through. And this is even more critical when we start talking and getting into C++ and header files, because when you're working with the header files, you don't have the rest of the code to look at. You just have the functions and the declaration. But we're talking about Java right now, so let's just stick with that. So after your header, you're going to want to have a line of asterisks followed by a space to separate your class's fields from your constructors and other methods. So you can see right here we have our fields that we're going to use for our class, and then down here we have our constructors, right? And so we've got this line of asterisks that helps separate those. Now, when it comes to your methods, you'll want to have a line of asterisks followed by a space and then a description of the method. The description should state what the method does, not how it does it. That's what your code is for, right? You'll also want to use line breaks with indents to separate long lines at natural points. You should never, ever, 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 ever need to scroll horizontally with your code. So like you can see here, we have this long string where we're talking blah, 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 something is an invalid name, yada, yada, yada. And we have this plus right here. So we're going to concatenate our string and have it flow onto additional lines. So we're not like trailing off over here off the screen, right? You're going to want to also add a comment to mark the end of long method or control structures. So, and again, this comes down to style conventions. Some have you do it, some don't. This is something that I never used to do, and actually it really helps out when you're dealing with method names that are really long, right? So you might get towards the bottom and you like lose sight of where you're at. Like, where am I working again? And so if you have a comment at the end of the code, you can say, oh, okay, I'm in set last, which is, a method. And you can use that for, for loops. You can use it for class names. You can see down here we got end class, right? We've got another end. So it just helps you understand where you're at in your code, because if you're working with a project that's 30, 40 lines of code, and maybe it's a small class, that's nothing. You're going to be potentially writing files that have thousands, tens of thousands of lines of code, and you really need to be able to find where you're at. And so this is one of those things that can help you do that. As a general rule, you should group your class members in the following manner. Remember, members are fields and or methods. Okay, so attributes and methods, so your variables and your methods. So you're going to want to group your variables first, and that means having your group variables followed by your instance variables. So remember, your class variables are going to be all your static things. So those are going to be the things that you can have without actually instantiating the class. And then your instance variables, if you'll remember, are those variables that you have to have an instantiated object to access or utilize. After your variables, well, and before I go on to the next thing, you're also going to want to group your variables by type, right? So I put all of my ints together. I put all my strings together, and I generally have, my ints followed by my floats, followed by my doubles. Now you don't have to do that. That's just something that I do to keep track of where they're at, because if you're working on a class or something that has lots of different members, lots of different attributes, then it really helps to be able to find them a lot easier that way. And then after primitives, I start using my reference objects. So like strings and whatever else I might have are going to show up in that order. Okay, so that's just one way to do it. Something to think about for your own coding standards. So after all of our variables, to get back on track, we're going to do our constructors next. And these are generally listed in order of the number of parameters. Okay, so you're going to have your default constructor first, and then you're going to have if you have 1 or 2 parameters, and then 3, and so on and so forth. And then after that, we put our getters and setters, or mutators and accessors if you prefer. And then finally, we actually list our other methods, including class methods and instance methods, just like the variables. Now, obviously, everything is separated by lines of asterisks as appropriate, and with the method headings and descriptors as needed, right? So, like with the mutators and accessors, you don't necessarily need to have a line of asterisks between each one, because they tend to be very short, and that would just clutter your code with unnecessary comments. So it's generally acceptable just to have all your getters and setters just listed together in one group. So now that we've covered coding conventions, and again, I didn't go fully into detail. You're a college student now, you can figure out how to read the style guide and know what's exactly, but those are the key things that I'm looking for. But let's talk about helper methods now. So as with all examples discussed so far, methods normally use the public accessor or access modifier. Now, public methods are considered to be part of the class's interface, right? Remember, an interface is how you interact with that object. Remember, our API is our application programming interface. But sometimes you're going to want to use methods that are not a part of the interface, right? They're just internal methods that help you do something inside of the class, and nobody using your class has a need to directly access them, right? So these methods are called helper methods, and they should use the private access modifier, because that will encapsulate your class so that way nobody can access them. So suppose you're asked to write a program that handles order entries for a sports uniform shirt company. For each shirt order, the program should prompt the user for a shirt's primary color and its trim color, like a blue shirt with, like a white collar and white cuffs around the arms. For each color selection, the program should perform the same input validation. It should verify that the entered color is one of three values, W, R, and Y, for white, red, or yellow, and that the input validation code is non-trivial. That is, it's in charge of prompting the user for the entry, checking to see that it's valid, repeating it if it's not, and then converting it to a actual color word string, right? So rather than having the input validation code appear every time that the color selection is needed, this would be a good place for you to use a helper method to implement the color selection task, right? So with the helper method, the color selection code appears only once in the program, and whenever the color selection is needed, the color selection method is called. So let's take a look at the program and see how this is done. So as you can see here, we have two files. We have the shirt driver and the shirt class, right? The shirt driver is very simple. We create a new shirt object, and then we do a blank line, and then we display the shirt. That's it, okay? So let's take a look at the actual class. So here you can see that we're inputting the scanner because we need to get input from the user, and we have three attributes. We have name, primary, and trim, okay? And you can see right here from the comments what they are. So here we have our default constructor. Notice that we actually have our own constructor. Here we are declaring a scanner object, and we are getting information from the user. So we're saying, hey, what is the what's your name, right? And then we're setting the primary color to whatever the select color prompt comes back with. Same thing with this.trim, select color equals trim. So what happens here is this is going to call the select color method passing in this string variable. So we come down here to set color, right? And we pass in the color type. So here we have a new scanner object because the scanner object that is declared here is not going to be available to us because it was declared only in the constructor, so it is not available outside of the constructor, right? It's a local variable. So we have to declare a new one. Now, we could have made it a class object and done it outside, but the author didn't. Okay, so here we have our string color, and it says do while. While we prompt the user for the shirt's color type, right, which we pass in as a variable. So in this case, up here, if we go with this first one, we're going to pass in primary. And so we come down here and we enter in the shirt's primary color, white, red, or yellow. And we get the input from the user from the console. And if the color does not equal W, R, or Y, then we're going to repeat it. And we're going to keep repeating ad nauseum until a user enters one of those three values, right? Now, this isn't a very robust program, keep in mind. It's not the point of it. There's a lot of problems with it. But it gets the point across. Then we have a switch. Once we have one of those three values, we can now set our color to the string based on what the user entered. So we have W for white, R for red, Y for yellow. And that's it. And it's going to return that color. So it returns, if somebody entered W, it's going to set the color to white, and then it's going to return white as a string. Then this dot primary will get set to the string white. And the same thing goes for select color. Now, notice that this really simplifies this code. Imagine if we had to have all of this code down here, right? All of that code up here in the constructor, and we'd have to do it twice. Or maybe if there was 3 color options, we'd have to put it in 3 times. So that doesn't sound very fun, does it? Right? So by moving some of the details from the big public methods into helper methods, you enable the public methods to be more streamlined and smaller. And so that can really help lead to program readability and maintainability. I think helper methods are pretty self-explanatory in understanding the utility of them. It's anytime you're going to duplicate code, you should automatically think about bringing pulling that code out into a separate method, because it makes testing easier, it makes maintenance easier, and it's just good for a whole number of reasons. Okay, there are some cases where you may not want to, but we're not going to really talk about that for now. For now, just as a general rule, if you're going to repeat the code, pull it out and have it as a separate method. But let's talk about encapsulation now, a little bit more in depth, and the benefits of it and why you should do it and when. So a program exhibits encapsulation if its data is hidden. That is, if its data is difficult to access from classes outside of the data's enclosing class, right? So why is this a good thing? Well, since other classes aren't able to directly access the encapsulated data, it's more difficult for other classes to mess things up, right? You can't break something if you can't get to it. So how do we implement this? Well, you can break a class's task into separate methods where each method holds a set of encapsulated data. Those data items are called local variables, as you should know by now. Additionally, we can break up a big problem into separate classes where each class holds a set of its own encapsulated data. Those data items are called instance variables, and they should use the private access modifier. Declaring data as an instance variable within a class is one form of encapsulation, and declaring data as local variables within a method is another form of encapsulation. So which one is stronger or more hidden? Well, an instance variable may be shared by all members of the class, whereas a local variable is local to one method. So a local variable is more encapsulated. So in the interest of encapsulation, you should use local variables as opposed to instance variables whenever possible. And here's how you can determine which to use. Declare a variable locally within a method if the variable needs to persist, that is to say it needs to remain alive only for the duration of the method, right? So once that particular method is done and this variable here is no longer needed, then it should go away. There's no need to hang on to it. Now, if you need to hang on to it for longer, well, that's where we can declare it as an instance variable. And we're going to do that if the variable stores fundamental attributes of the class's objects. So you can see we pulled the variable out of the method and made it part of the class. And you do this if it needs to last longer than that particular method. So if it's something that multiple methods are going to use time and time again, then pull it out and make it a class variable.